Okay, in this video we're going to be talking about the Leontief input-output model. Now I pronounce it Leontief, it could be pronounced another way. But it's going to be for a single sector economy, which we're going to explain more in this video. But we are diving into the world of goods and services. And, like a business provides a service or creates something for the general public. What is the internal consumption, what is the external consumption, and of course we're going to talk more about that in this upcoming video. So let's go ahead and just get started. What we're going to do is we are going to analyze the flow of goods among sectors in an economy. Now the best way to explain this is just to go ahead and dive into a problem. So suppose you own a company that produces batteries. The machines that make up the batteries also runs on the company's batteries as well. It takes 3% of the total population of batteries for the machines to operate. So this is what I want you to kind of visualize for a second. All right, we have a machine, and we'll just call it, there's our machine, okay? Now on this side of the machine, let's just say there's a conveyor belt going into this side of the machine, and forgive me how crude the drawing is. So we have going into the machine all of the different little raw materials that make up what makes a battery. So, here's some metal here, here's some, I'm sure, copper here, here's just some other information, other stuff that goes into it, okay? Now, what happens is all this raw material goes into a machine, and what comes out on the other side on this conveyor belt is the actual battery itself. Okay, so let's see if I can draw this really quick. All right, there's our batteries. Okay, now our batteries are leaving the machine and they are going to, I guess, what would be the packaging area. Now here's another thing to take note of, and in the question it also says that our machine runs on the batteries that it produces. Okay, so it runs on its own batteries, so to speak. All right, now a couple of things that we want to take a look at is this, and that is the fact that it runs on 3% of the total population of batteries. So 3% of the total population. So what that means is, let's just play the what if game, so to speak. Let's say if the machine actually produced 100 batteries. So if it produced 100 batteries, and I'm writing with my mouse here, so forgive me for it being a little crazy. So if it ran on, or if it made 100 batteries, then that means it would have ran on 3 batteries. Or in other words, 3 batteries would be used to run the actual machine. Okay, so there's an actual formula that we're going to run with in this section, and that is this right here. P minus little p times big P equals D. All right. Now each of these formulas here, or each of these variables, means something. Notice that there's actually 2 p's here. So that means whatever's being produced will be inserted twice into the formula. Okay. Now I'm going to ask you to go ahead and pause it because I'm about to go to our next question. So if you need to write this down, feel free to do so. If not, here we go. All right, here's our question. The number of batteries produced versus the number of batteries can be expressed in the following. So this right here is a continuation of our last question, which was the whole 3% of the total population, okay? So the percentage will always be given to you. That's what I want to make sure that you're aware of. The percentage, ooh, that is not a good color, will always be given to you, okay, in a problem. And so this is a big P minus little, or if going back to this problem here, notice how it was big P minus little p. That represents the percent written as a decimal. So our percent was 3%, written as a decimal is 0.03. Okay, so this is the formula that we're going to be using. So going to our problem and keep working on it. If we were to go to this part here, how many batteries must be produced in order to have 5,000 available for external sales? Okay, so 5,000 available for external sales. Now, remember, the question states is how many must be produced. So that means we're going to be looking for P here. Okay, this 5,000 it's referring to external sales, which means what is going to go to Walmart, what is going to be put on the shelves at a Target for the consumer. So what's going to happen is this 5,000 is actually going to go in for D, which is right here. Okay, and we're actually going to solve for P. So when we solve for P, our next step is, or as we set up our proportion, not a proportion, I'm sorry, but when we set up our formula, it's going to be P minus 0.03P equals 5,000. Now, this next step usually throws people off because what we're going to do is, in the rules of algebra, we are actually going to take this information and we're going to combine it, combining like terms. Now, remember, there is an unseen 1 that's in front of this 1p. So when I take 1 minus 0.03, I get 0.97p equals 5,000. Now, from here is nothing more than a middle school math problem where I'm just going to divide by 0.97 and divide by 0.97, and I get my answer, which 5,000 divided by 0.97 is 5,154 batteries, and it's not a clean number, so it's going to give me a decimal. So I'm just going to go ahead and round up, since we're talking about batteries, and so we're going to round to the nearest whole. 5,155 batteries. So that's how many had to be used. Okay. Now from this information, I can ask you a couple other questions like this: how many batteries were internally used? Well, we know that 5,000 actually went to Walmart, so to speak, and it produced 5,155, so we'd take the difference. So 155 batteries were produced. Oh, I'm sorry, not produced, were internally used. All right, let's go to another question. At the end of the week, your battery company produced 15,000 batteries. With a consumption rate of 7%, how many batteries were available for external sales? Now, remember, guys, that you're dealing with the formula, which is P minus little p times big P equals D. Now remember, now you're in the problem, it's telling you how many were now produced. Okay, the company produced 15,000 with with a consumption rate of 7%. So I'm going to take all this information and plug it into my problem. So the 15,000 number goes in there. The 7% will go into little p, and when you're talking about external sales, it means you're talking about D. So when we solve for this, it's going to be 15,000, and remember I'm writing with my mouse here, minus 0.07, remember convert that to a decimal, times 15,000 equals D. Okay. Now from here, you're not really solving for anything when it comes to algebra, like substituting or anything. It's just basically just figuring all this stuff out. And so when we get our answer, it is going to be our demand is going to be 13,950 batteries. All right, pretty simple. Okay, the last problem that we're going to do is this one here. Okay, I just went ahead and took away the word problem. We don't know how many we produced. We don't know how many went to went to Walmart, so to speak. But we do know that the internal consumption was 275 batteries, and the consumption rate was 4%. So if this is ever an issue, what we're going to do is we're going to take our original formula and we're actually going to cut out the center of it. And we are going to now do little p times big P is equal to IC, which IC stands for the internal consumption. So now with this information here, we're going to take this 4%, we're going to put it right here. We're going to take this internal consumption rate, put it right here. So this way we're going to be able to figure out our total production. And so it should look like this. So when I solve for this, it would equal 6,875 were actually produced. But here's what I want to bring to your attention. If I produce 6,875 and my internal consumption was 275, it's nothing more than a simple subtraction problem to get how many went to Walmart, so to speak, for demand, which sticks at 6,660. So if you have any questions, let me know next time you see me. Thank you.